Hi there, let's learn programming. So today I thought we'd look more at classes and inheritance, which is a central topic in object-oriented programming. As last time, I have in front of me BlueJ, and to improve a bit upon last time, I've set it up a bit differently so that it'll be easier for you to follow along. I've increased the font size and made things a little bit bigger so they will appear more clearly on the video. So let's look at the code we have in front of us today. As you can see, we have these two classes this time. First we have this dog, and then we have this animal class. And you can see that it says that this animal class is abstract. We'll get into the meaning of that in a second. If we look at the dog class, we can see that it is empty. Doesn't really have anything in it, but it has this funny little keyword, extends. And it extends animal. So let's make a dog. As usual, we right click and click new dog. And we'll just dog one, that's fine. If we right click on this object, we can see that it has something inherited from animal called getType. And if we run that, it prints back to us the string dog. So without having any function inside the dog class, we can get back that it's a dog. Now, let's have a look at this. When we click new class, as you saw last time, we have these options for a class, an abstract class, or an interface. We can also make unit tests, but that's different. There's also enums and JavaFX, but that's for later. As it says here, the animal class is abstract. Let's click into it and see the code. As you can see, it's declared abstract in front of the class keyword. Now, what this means is, if you imagine when you instantiate an object that you create a specific entity of that type. Well, with something like animal, you can't just have an animal. You can have a dog or a duck or a cat or a rat or snake, bird, I don't know, whatever, right? But you can't have just an animal. An animal is sort of a super category where other things sort of are subcategories of animal. And that's what this abstract thing means. It means that you cannot have just an animal. An animal is a super thing that we can extend, and you can become an animal, but then you have to be something else as well. Like our dog was. As you saw, it had, and it still has for that matter, this keyword, extends animal. Right, so let's look at this animal class here. What it has is this getType thing, which just prints whatever the type of the actual class is. The concept of extending another class, though, isn't just limited to actual classes extending abstract classes. You can extend any class, which means that even if we remove the abstract keyword and recompile, it'll still work just fine. You can still have dog extend animal. However, now we can also make just an animal. So the abstract keyword allows us to limit that and say that everything within the class of animal has to be abstract. You cannot instantiate it. The idea behind extending other classes is to avoid code duplication and simplify things. Instead of needing to have this getType thing in every single one of our animals, we can have just one animal that implements this, and then that functionality will be inside every single animal for free. But we can also extend the dog specifically with extra functionality. Like, for instance, what's specific to a dog? Maybe it has a function called or a function that returns a string called smell. Smell with an E, which just returns I smell food. Right. So maybe some animals don't have noses and they can't smell. So we can implement that inside of the dog. So now any animal can tell you what type they are, that they are specifically a dog or a cat or whatever, but only dogs can smell. So as I've demonstrated, this idea of inheritance covers these member functions here, or member methods. But it also covers field variables. So if I in here say that every single animal has an integer, which is their age, and I'm using here this protected access modifier, and we'll talk about that in a future video, probably the next one. But for now, just make that protected. So if I say that every animal has this age integer, if I go over to our dog and I say public and GetAge, and I just say return age, close it. If we go to our overview and we compile and we instantiate a dog, dog1, you can see it has the variable getAge, or the method getAge, which returns 0. Now it returns 0 because we haven't actually set an age, and 0 is just the default integer. You can see we set no age variable anywhere, we just declare it, so it'll just default to 0. But we can use this age variable even though it's declared in the superclass. Another thing we can do is extend or override functions from our superclass. So if I in here make a method public void called printAge, which just does system.out.print age, and that's it. Well, if I go back over here to our dog, what we can do is we can say override, and you can see that actually flags up as an error right now. That's good, because it's just telling us that what we specified to override, well, right now it's not overriding anything because we haven't actually told it what to override yet. So below this, we'll say public void printAge, and if we just close that off and click compile, you can see that the error with the override message went away because now we're actually overriding something. So that's happy. Now, in here, we can say system.out.print. This dog is, and then we do something interesting here. We say super.printAge, and super here refers to the superclass, the parent of this object. So the dog will be an animal and super will be the animal class. And then we can go system.out.println years old. Now you probably already figured what this does, but let's just run through it and see if it's what you expect. New dog, doggy, and in here we'll use the printAge method. And as you can see on the terminal on the left here, it says this dog is 0 years old. So what it did here is actually that it called the print method, and this bit here, this dog here, that comes from the dog class itself. This 0 here is actually being printed from the method call in the animal class. This right here, which prints the age. And then the last bit comes again from the dog class. And of course we need to discuss this override annotation here. because this isn't strictly speaking necessary. If you don't have this at all, everything will work exactly the same as I've just described. This here exists just to give us an error message, because let's say I had written this wrong, and instead of saying print age, I had said print ages or something. Well, we wouldn't immediately see that there's a mistake if we didn't have the override. Because we have this override, it won't compile anymore. It'll tell us that this isn't actually overriding anything. But if we didn't have that, we'd get no error message, which means that what we're actually trying to accomplish here, which is overriding the print age method, wouldn't work, but the code would work anyway, and we'd just get the program not doing what we expected. So the at symbol and the override annotation is just there so that we get an error if we accidentally misspell things, which is kind of nice. Now, I've once heard that dog years are about 7 times as long as human years. So let's do some arithmetic here. If we start out by giving the animal class a GetAge method, so public int GetAge. We already have this in our dog, but now we put it in the Superclass as well, which means that technically the one in the dog class is now overriding this one. And let's just tidy up here. Let's say that the print age method here, instead of just getting the age variable and printing that, it'll use the GetAge method. And if we go over here to our dog, I guess I was wrong, we didn't have a GetAge in here. So let's make that public int GetAge. And we'll say that that will return age times 7. Now, if you remember back in our last tutorial, you'll know how to make a constructor. So let's make a constructor for our dog that sets the age. So we'll say dog. We'll take as input the age, and we'll set the given age to be equal, or we'll set the dog's age to be equal to the given age. That'll be that. So, what do you think will happen now when I make a new dog and I give it the age 5, and we in here click the print age method? This dog is 35 years old. Because we are, of course, using the print mechanism we made down here, and the age we get from this call here uses the GetAge method. But it's not this GetAge method that just returns the age. It's the GetAge method on the actual object. So in this case, that would be our dog. And that one doesn't just return age. That one returns age times 7, which will then be the value that's printed out in this call. Isn't that cool? As the last part of today's lesson, we'll look at interfaces, because they neatly fit into what we've been talking about today. So if we click the new class button and we title it animal interface, and we pick the interface button here on the menu, click new, we get this interface thing. Now it very much looks like the abstract class, it just says interface instead of abstract. That's because these two things are actually sort of similar. Let's enter it and have a look. Let's clean up the clutter a bit. Get rid of this. And that. There you go. So as you can see, it's got this method here. But unlike before, we have no open and closing curly brackets. And if we try and insert them, that's not allowed. We get errors. And interface abstract method cannot have a body. So what does that mean? This is because an interface, unlike an abstract method or a regular class, or unlike an abstract or regular class, I should say, it's not something that defines behavior or state for that matter. In an abstract class, we can say that all animals will probably have a sort of similar function for getting their age. So we can define that right in there. But an interface is more like a contract. It says to be an animal, you need to fill out these properties. You need to have a method that does this. Now, it might be so that every single instance, every single class that implements this interface will need to do things in such a different way that we can't specify a default method that should be performed. So an interface just says that if you implement this interface, you need to have these things. You need to have a method that is like this, that has this method signature, right? It needs to be called sample method, return an int, and take an int if it's like this, right? And if we go over to our dog here, it says that it extends animal. Well, we can also say that it implements the animal interface, right? But then we'll get this error here. It doesn't override the method we just had in our interface, this sample method, because clearly the sample method is not inside this dog class. And it's also not abstract. And the reason it says it's also not abstract is because if you have an abstract class, it's okay not to implement or not to have the method for this interfaces class or interfaces method, because you're abstract, you can't be instantiated. You just need to make sure that any subclasses implemented. So if I delete this again and we go back to our abstract class here for animal, if I instead write implements animal interface in here, this file will compile just fine. But then if we go to dog again, we'll get this error here, which is exactly the same as before, because now it's the animal class that we're trying to extend that demands that we have this sample method from the interface, right? So let's delete this, and everything's fine again. There are a number of different sort of standard interfaces in Java that are really good to implement in your classes, at least if you're going to utilize some standard functions that depend on them. These are things like hashable or comparable, and these allow you to do things like use standard sorting functions. So if you have a list of your own custom dog objects, if you implement the comparable interface, you can use the standard sorting algorithm inside Java to sort them based on age or breed or whatever you want. It's a really powerful tool, and we'll look more at that when we get to the substitution principle. But for now, this will be the end of this video. So I hope you enjoyed this and you learned something. And as always, really don't worry about it if there are still some things that are unclear or that you haven't learned yet. We'll get through it all eventually, I'm sure. You can always rewatch this. The code will be available. I'll try to see if I can link it in the description as usual. And if you enjoyed this, please do leave a comment, give it a thumbs up. If you really liked it and you want to see more of this, subscribe. I will be posting more of these videos, and it'll really help out. I'm just starting out, so every little really helps. Thank you again, and happy coding.